let's talk about how to calculate the confidence interval of a mean. Let's say that we have a data set that has a mean of 20, standard deviation of 5, and a sample size of 50. Okay. So if we want to calculate a confidence interval for this value, so what we're saying is that in our sample, we've calculated the mean and it is equal to 20. But in our population, we have not sampled the entire population, of course, but if we were to, how confident could we be that that mean of 20 was close to the population mean? Okay, we want to come up with a confidence interval, and let's say in this case our confidence level we want to be equal to 95%. So because of the central limits theorem, we know that this mean of 20 sits on a normal distribution of a theoretical normal distribution. Not that the data set from which the mean was calculated was normal, but that it itself sits on a normal distribution. A normal distribution of other means, other samples' means. And if we move out in either direction until we have occupied 95% of the area under that curve, so that the area that I have filled in here represents 95%, that would mean then that we have, well, 95% here in the middle, 2.5% out here, and 2.5% out here, right? This distance that we move away from that mean represents our confidence interval. Okay, so if we had a mean of 20 and a confidence interval of 2, what we would be saying is that we are 95% confident that our population mean is equal to 20 plus or minus 2, or that we are 95% confident that in our population the mean is somewhere between 18 and 22. Okay, and I just got that. Right, 20 minus 2 equals the 18, and 20 plus 2 equals the 22. So that gives us our confidence interval. Here I'm just cleaning off my workspace so that I'm not making any mistakes by having some variable from a previous analysis being retained. I'm opening up the trees data set, and here I'm attaching those data. I have in the trees data 31 variables, 31 observations on 3 variables, and those variables are the girth, the height, and the volume, lumber volume in those trees. So let's say that we wanted to make an estimate about the mean amount of lumber, so the volume per tree. And I can calculate the mean here and discover that that is 31, or sorry, 30. But that's based on my population, on my sample. So this is the sample mean, right? And I want to get to my population mean, which is that mean plus or minus a confidence interval. And I calculate the confidence interval by establishing a confidence level. Let's say that I want to be 95% confident, and I also need to know my sample size here, which is the 31 that we already talked about before. Okay, so to do that, I need to come up with a z-score, or I need to know how many standard deviations do I move in both directions away from that mean of 30 until I have encompassed 95% of all estimates of samples means. And so to do that, I'm going to use the QT function. And because of the way R is written, I need to have that 95% plus the lower tail of 2.5%. And so this may be a little bit, maybe not the way everyone would do it, but I just habitually type that. So I've taken my confidence level of 95, I add it to 1, so 1.95 divided by 2, and that gives me the 97.5. And I do it that way simply so that I don't have to remember that to get a 95% confidence, I need to put in 97.5. Okay, 97.5% or 0.975. So to avoid having to remember to do that, to do the mental math, I just habitually type out 1 plus the confidence level divided by 2, my sample size here for my degrees of freedom. And so we are moving 2.042 standard deviations down the number line and up the number line from our population or our sample mean. Okay, and we're doing that not on the distribution of the volume variable itself, but on a normal distribution of estimates of samples means of volume. To convert that back to real units instead of in units of standard deviation, I'm just going to multiply z times the standard deviation divided by the square root of n. So I already have n, but I haven't calculated my standard deviation yet, have I? So here's the standard deviation of my data. Of my sample is 16, and when I put that into my confidence interval function, it is 6. So I am 95% confident that if I were to sample all of the trees in the forest, based on this sample of only 31 trees, that my population mean is somewhere between 24 and 36. Okay, so that's how I get my confidence interval. The confidence interval itself is 6, and the thresholds of that confidence level are 24 and 36. So I'm 95% confident that the total volume of each tree in my forest is somewhere between 24 and 36.